Welcome to SOLO, Mapping the Climb from Surface to Deep Learning. This video offers a visual playbook for understanding the structure of Observed Learning Outcomes framework, also known as SOLO. Traditional assessment often falls into the quantity trap, focusing on how much a student knows. SOLO helps us move toward a quality map, focusing instead on the structure and coherence of a student's understanding. It asks, how well is your knowledge structured? SOLO, or Structure of the Observed Learning Outcome, measures the complexity, not just the correctness, of a student's response. It progresses through 5 levels: pre-structural, unistructural, multistructural, relational, and extended abstract. The surface phase involves gathering the bricks. This includes pre-structural, where the point is missed, unistructural, focusing on one relevant idea, and multistructural, where several independent ideas are present. Key verbs here are identify, name, and list. The deep phase is about building the structure. Relational thinking connects the ideas into a coherent whole. Extended abstract allows the structure to be generalized beyond the immediate context. Key verbs include compare, contrast, analyze, and generalize. SOLO differs from Bloom's taxonomy. Bloom guides teacher planning, focusing on intended objectives. SOLO, however, guides student self-assessment, focusing on observable, student-centered outcomes. Deep learning requires constructive alignment across the whole ecosystem. The intended learning outcomes, teaching/learning activities, and assessment tasks must align for deep learning to be accurately assessed. If one element focuses on surface facts, the system breaks. The learning log is a strategy that breaks a single topic into 3 tiers of SOLO complexity, giving students a clear dashboard for their progress. This helps students see the next step clearly, such as moving from defining to explaining, and finally to predicting. In this primary science case study, students progress from uni/multistructural, where they define terms, to relational, where they explain connections, and finally to extended abstract, where they can hypothesize consequences. In higher education mathematics, SOLO helps diagnose where a student stopped climbing. Instead of a binary right/wrong exam, the SOLO methodology structures the problem into progressive steps, revealing if the blockage is a calculation skill or a conceptual link. Hexagonal thinking is a strategy to force relational thinking. It's a tactile activity where students physically connect concepts and, most importantly, annotate the connection points to explain why those concepts touch. Empowering student self-assessment means shifting the feedback loop. Students code their own work against the SOLO rubric, moving from asking, "Did I pass?" to asking, "Did I connect?" The impact of using SOLO is a shift from clarity to competence. When students have a clearer understanding of the expected depth of thinking, they are more likely to climb the learning ladder and achieve higher levels of excellence. SOLO supports the pyramid of the lifelong learner by focusing on building the cognitive processing needed to tackle new subjects. It moves beyond just passing tests to establishing clarity and effort as the foundation for lifelong learning. The takeaway is simple. Don't just teach the content, teach the climb. Provide a common language, a visible map, and a feedback loop that uses assessment as a tool for climbing the mountain of learning, from pre-structural to extended abstract.